Okay, students, let us start with the class. So, in today's class, we will be discussing LR parsing. So, in LR parsing, it is also called as LR0 and SLR1. Why the name LR parsing? That is the first question we have to answer. L means we are scanning here also input from left to right. That is the reason we call it as LR parsing. Okay. This L stands for left to right. And what about this R? Rightmost derivation in reverse. Okay. So we consider rightmost derivation in reverse and we are scanning the input from left to right. That's why we call it as LR parsing. Okay. So in LR0 automation, what happens? We will be moving the dot. Okay. So what do you mean by moving the dot? What do you mean by moving the dot? That you will understand later. But right now, you just try to understand. If in the first stage, if the dot is here, in the next stage, the dot will move one terminal or non-terminal after that. In next stage, like this. Next stage, like this, and this is the last step. Okay, this we will do. This we will understand. Okay, how to do this. But you just know in LR0, we will be moving the dot. Okay, in each and every step, we will be moving the dot, and when it comes at the end, we will stop that particular procedure. So I said LR parsers are powerful. Okay, it is based on the bottom-up parsing. If you recall, in the beginning, I had told you there is top-down parsing and bottom-up parsing. In bottom-up parsing, LR parsers are powerful. Why? Because we have few reasons. It can be constructed to recognize virtually all programming language constructs for which context-free grammars can be written. You know that many programming languages are there: C, C++, Java, C Sharp, many programming languages. So this LR grammar can be constructed to recognize any kind of grammar which accepts or which is able to construct a context-free grammar. If it is compatible with context-free grammar, you can apply LR to the particular programming language. And it is not having non-backtracking shift reduce parsing method. Means it is not having backtracking problem. You know that if backtracking is necessary, it will be time consuming process. Okay, so here we don't have any backtracking. That's why we call it as it is non-backtracking shift reduce parsing. Okay, backtracking is not there. That's why we call it as powerful technique. And it can detect a syntactic error as soon as it is possible. Like uh, what is the role of compiler? As soon as possible, it should be able to detect the syntactic error. It is doing that. Okay. uh, on a left to right scan of the input, already we told it is always doing left to right scan of the input. It is finding the syntactic error as soon as possible. And LR grammars can describe more languages than LL grammars. This is very much related with the first point. I said many languages are supported. Here also I am telling many languages are supported. Okay, previous method we learnt is LL. This was given in your internals, right? This was given in your internals. Okay, so now we are learning LR. So till now what we studied, what is LR parsing? Okay, why the name, why do we have L and R there? L indicates left to right, R indicates rightmost derivation in reverse. Okay, and why it is called as powerful technique. Okay, so once again, let us consider the example. Okay, consider the example. So what is this example? By holding this example, we will be we will be understanding LR parsing. So this grammar is very, very important. Means this is the example I am considering. Okay, so this example, write down this as an example. Okay, this example. So, what is step one? Step one is rewriting and numbering. Okay, in LL, the rewriting is different. There, you are making it left recursive, or like removing the left recursion, making it left factored. Those things are not there here. Okay, here, what you are supposed to do is look here. I'm rewriting the productions in like separately. Like, for example, if I have E produces E plus T or T, I will write E produces E plus T as one grammar and E produces T as one grammar. So that's what I have written. Are you understanding? The first grammar is rewritten into two productions. The first production is rewritten into two productions. And similarly, next grammar will be rewritten. T produces T star F is one production, T produces F is one production. So this this production is rewritten into two productions. Are you understanding? Similarly, here also, this one we will write F produces open brace E closed brace and F produces ID. So what happens? We initially had only six productions and we rewrote it. Okay. So now we have, sorry, initially we had three productions, it became six productions now. Separately, we are writing. Okay, what is step one? Step one is rewriting it in this way. You have to remember, and then numbering. So, how do you number it? So, how many ever productions you have? Those many numbers: one, two, three, four, five, six. Okay, this is the first step. Note down, students. Step one is rewriting the grammar and numbering it. Rewriting means what? If you have two productions, X or Y, X you are writing differently, and Y you are writing differently. Okay. So what is step two? You're very much familiar with the step two, students. You're finding first and follow. For the given grammar, you're finding, for the given production, you're finding first and follow. So let us check first and follow. Okay, first of E is first of E plus T, which is nothing but first of T. Okay, and again first of T is first of T star F. Why? This is because here we have E produces T, right? Okay, that's why first of T. First of T is first of T star F. So what is first of T star F? It is first of F. And similarly first of F is first of open brace E closed brace. So it will become open brace only. And first of ID is ID. So first of F is together you have open brace and ID. Okay, so the open brace and ID, open brace and ID. Okay, so many times we dealt with the finding the first. So now we found first for E, first of T, and first of F for all the non-terminals. Next is follow. So how to find the follow? You know that follow should be started from here and then all the non-terminals in the RHS. So first, whenever I'm finding follow of E, it should be dollar. Recall, it is dollar. Now what happens? I have to check whether E is present anywhere in the RHS. Yes, E is present here. E is present here. So I should find follow of E. Follow of E is follow of, first of T. First of plus T. So it will become plus. And similarly, one more follow of E, it will become first of closed brace. Okay. So together follow of E is dollar plus and closed brace. And now I should find follow of T. So follow of T is nothing but follow of E. Okay, you know that. So here T is there. Here also it is follow of E. Here also it is follow of E. Okay, and I don't, here I have again follow of T. That is follow of T itself. Okay, so I got follow of T is dollar plus and closed brace. And follow of T in this case, what? First of star F. So since star is terminal, I will get star only. So together if I write follow of T is dollar plus closed brace and dollar. Sorry, star. Next I'm supposed to find follow of F. So F I have here, I have here. So this follow of F is follow of T. Follow of T is dollar plus close brace star. Okay. And once again, this follow of F is follow of T only, so no change. So this step two is finding the first and follow. I repeat, what was step one? Step one was rewriting grammar independently, like each and every production separately and numbering it. Step two is finding first and follow. Okay, now what is step three? Converting the given grammar into augmented grammar, that is just step 3. So how do you do it? Very important. How do you do it? Very simple. We have to add one extra production. Okay? We have to add one extra production. On what basis we are going to add extra production? Add extra production. On what basis we are going to add extra production? That is based on the first production. I'm telling you. Here in the step 3, you are going to add extra production based on the first production, whatever you have. For example, if you have E here, you will write E dash. Produces E. Okay, are you understanding? So we will add extra production based on the first LHS whatever is present. Okay, so E dash produces E. That's what I have written here. So this is step 3. This is step 3, very important. So it is always LHS dash. Both LHS and RHS should be having the same terminal with dash. Okay, it can have different items. E dash is different, E is different, but the convention is like this. So whatever the first non-terminal is there, that you take and you rewrite it. Okay, this is important, step 3. Okay. And after that, we are having, after step 3, we are having, okay, here one more thing, you need not have to include number in the number. Number will start from this production only. Number will always start from this production only. This you should not include for numbering. Okay. Next, we are going to, okay, just repeat whatever we studied till now. We studied step 1, rewriting and numbering. Step 2, finding first and follow. Step 3, adding extra production. So before going to the next step, we should be knowing 2 concepts. So which are those 2 concepts? Those 2 concepts are item construction concept and go to concept. Item construction concept and go to concept. Okay. So first one, let us understand what is item construction concept. So I have just written, so if you observe, whatever there in the previous slide, same thing I have written with one additional thing. So what is that one additional thing? Can you observe? There is a dot added here. There is a dot added here, 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 dot added here. Okay, so what is the actual procedure I am following? That is very important, right? What is the actual procedure I'm following? Okay, what we do is initially we will consider the first production, that is augmented production, whatever you added. Okay, so after this, what happens? I will just look. Okay, after adding dot here, I will check whether any other production are there which starts from E. So if you observe, yes, it is there. Okay, which starts from E, this one is there, this one is there. Okay. Okay, now what I will do, I will add dot to the production, and now I know that there are 2 other productions. Okay, there also I will add that dot. Okay, and now I will observe in this, is there any non-terminal, which is having dot beside it, behind it. Okay, here E is a non-terminal and there is a dot present there. Okay, I have to recursively start writing what the reproductions. So already I have written, right? So I will consider this T. beside or behind this T also there is one dot. So I will consider all the T's productions. I have T produces T star F. There also I will add dot. Okay. And similarly, I have T produces F. There also I will add dot. Okay. Now I have to once again check, is there any non-terminal for which you have dot behind it? Yes, F is there. Then there also for F dot close bracket, sorry, open brace E close brace. And F produces ID is there. There also you will add dot. Okay. So this is non-terminal. Sorry, this is terminal. Open brace is a terminal and ID is a terminal. Open brace is a terminal and ID is a terminal. Okay. So by this sense, now dot is no more present beside any non-terminal. It is present only behind terminal. So I need not have to continue it further. I repeat, what we did is we just considered the production in the previous slide and we inserted dot at the first production. Whenever there is a dot behind the non-terminal, you should keep on adding that dot to all the productions of its kind. For example, here E is there. So I consider two E productions, added dot is there. Now I'll re-look into it. Again, T is a non-terminal which is having dot behind it. So I will consider two more productions which start from T, I will add. Again, F is a non-terminal which is having dot. So I will consider F. But now I don't have any non-terminal which is having dot behind. So it's completed. Now, same thing is, I'm going to call this as state I naught. Okay, item or whatever I naught I can call it as. Okay, so this same thing is given with the algorithm. Okay, so what is this algorithm says? Closure of item sets. So what do you mean by closure of item sets? If I is a set of items for a grammar G, okay, here we have so many items in grammar G, then closure of I is the set of items constructed from I by two rules. Okay. Initially, add every item in I to closure I. You just add every item in closure I, and then if alpha dot b dot beta is in closure, understand this. B indicates non-terminal. B indicates non-terminal. So whenever you have a dot behind this non-terminal, then you should add one more production, B dot gamma. If B dot gamma is there, you should insert B dot gamma. You should do it recursively till when? Till the dot is no more present behind any non-terminal. That's what we did here, right? Initially E dash star E. E is a non-terminal. So I will consider all the productions which start with E and added dot. And I will relook into it. Then T is a non-terminal. Then I will consider all the productions which start from T and I will add dot into that. And here F is a non-terminal and I will consider all the productions which start from F. And this open brace and IDs are terminals. So it is stopped there. Okay. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ ಫಾಲೋ ಮಾಡ್ತಿದ್ದೀರಲ್ಲ First,
Yes, ma'am.
we just consider the grammar and we rewrote it and numbered it. And then we found first and follow. Step 3, we just wrote a augmented grammar. Then we are learning how to itemization. It is construction of items. Okay. Okay, that's what we understood. Next is go to. Okay, consider the same set of production in the previous slide. Okay, so what we will do now, observe each production where dot is present. Okay, observe each production where dot is present. Then what happens? What happens? So this we will better understand with the example. Look here. Go to is applied to any item on X. Okay, then what happens? If you consider this production, look here. Here dot is there. Where is dot? Dot is here. Okay, if you apply go to like this, if you apply go to, then what happens? Dot will move forward. That's what is happening here. Dot will move forward. And similarly here, if it is applied. If go to is applied to E, what happens? Dot will move forward. That's what has happened here. Also, dot will move forward. That's what has happened here. Okay, this is on E. What happens on T? Okay, look here. I will rewrite it. On E, E dash E dot. On E, E dot plus T. Okay, and here I am following one convention. Whenever this dot whenever this dot moves to the end of the expression or production, whenever this is moving to the end, dot is moving to the end, I'm changing the color of that particular production. I'm changing the color of that particular production. That's what I'm following here. If you observe what happened, these two productions got changed like this on applying go to. We know what is the concept of go to, we discussed in the previous slide. Then what happens? If at all the dot is moving till the end, I'm changing its color. So now on applying T, what happens? E produces T dot, E produces T dot, and T produces T dot star F. Okay. And uh, next on applying F, T produces F dot. Okay. Next on applying close open brace, that will give you E F produces closed brace, open brace dot E. Okay. And once again, look here. Here, dot came into an end. I just change the color. Instead of black, I'm having some other color. Here also F came into end, some other color. Okay. And here it is very, very okay. While finding item, what is the rule we've studied? If there is a dot behind a non-terminal, if there is a dot behind a non-terminal, we have to rewrite those productions. So I'm rewriting those productions. What are those productions? E produces dot E plus T, E produces dot T. Now once again, dot T is there. T is a non-terminal. If dot is behind non-terminal, rewrite those productions. T produces star T, dot T star F, T produces star F. Once again, dot F is there. That means F produces open, like this productions. These two productions you are going to rewrite. Are you understanding? We are recursively following. If there is any dot behind non-terminal, you are going to write respective productions till you get the end of it. End means the dot should not be present behind any of the non-terminal. So if you observe, this I am naming as the item number 0, item 1, item 2, item 3, and this should be item 4. Understood? Okay, this is on applying ETF open brace. Now, on applying ID, what happens? On applying ID, what happens? F ID dot. Okay, this is item 5. Okay, same thing should be repeated in the next step. Same thing should be repeated in the next step. What we are supposed to do? What we are supposed to do is whenever there is a E dash, okay, you know when we entered this. Okay, directly we are going to write dollar. Directly we are going to write dollar. Okay, that means it is accept. E dash produces E dot is accept, acceptable. Next, okay, accept we have written. Next, what happens? You just remember in each and every stage, what is my intention? I want to move the dot further. I want to move the dot further. So here, how can I move the dot further? Okay, if I apply plus, this dot will become after plus. That's what I did. Okay, this dot become after plus. So since there is a dot behind non-terminal, you have to write those productions. T produces star T star F. Here I am having those. T produces star dot F. And then again here F is present. F is sorry, dot is present behind F. So I'm going to write F productions also. Okay, so you here you have F produces dot open brace E, close brace, and F produces dot ID. Okay, I'm calling this as item 6. Next, on star, once again, what happens? The dot will move forward. So it will become T produces T star dot F. Here again, the problem is dot is present. Where dot is present? Behind a non-terminal. Whenever dot is present behind the non-terminal, you have to write all those productions. So you will get F produces dot open brace E close brace and F produces dot ID. That is I7. And here you do not have to move the dot further. It is already moved further, but here you have to move further. So on applying E, what happens? After E, the dot will come. Okay. Here also after E, the dot will come. Next is on applying T. If you observe on applying T, what happens? T dot, it should happen. It is already here. And here also T dot star F, it is already here. These two things are already there. So we need not have to go to new state. If I think I naught as one state, I1 as one state, I2 as one state, I3 as one state, I5, I6, I7, I8 as one state, what happens? This will go here. Okay, because on applying T, this is what the result I'm going to get. And similarly, T is produces star F will become F star. So I have it here. Okay, I'll change the color. Okay, for this on production F, it's here. And this one, open brace dot. Open brace dot is here, right? So it is self. It will come to self on this. That's why we have self. And this id dot is here. So on applying id, so it will come here. Okay. Okay. Next. We should continue further, right? Here also dot is not at the end. Here also dot is not at the end. Here also. So we have to continue. So how to continue? On applying T, what happens? The dot, this particular dot will move after T. In E produces E plus star dot T, it will become T dot. And similarly, T dot star F. Okay, then F. This is only on applying T. Okay, but here you have dot F also. That means it should become F dot. Okay, you have that state here. Okay, so on producing F, it will come to this state. And here it should become open brace dot E. Okay, that we have here. And id dot on producing id, that is here. I just connected it like this. Here and here, it is only single connection. Then here also, I should move this dot further. For that, what is the way? Okay. On F. Okay. Next is on closed brace. Okay. It will become dot E. That is there here. On dot ID, that should become this arrow. Okay. Once again, I'm considering I8. Okay, after considering I8, open brace E dot. So on closed brace, it will become end. The dot will be placed in the end. And similarly, on plus, look here. On plus, this particular arrow. what happens? I should get E plus dot T. Where it is there? It is here in I6. So I8 will go to I6 on plus. So that's what is written here. That's what is written here. Got it. Okay. Now what happens? It is still not reached end. When it will reach end? When the dot is in the rightmost position. So this T dot star F, it will become T star dot F. It is already here. So I am showing this state on star. Okay. So this completes. So if you now observe here, we are having all colored thing. If you observe, dot is in the end. Okay, E star, E dash E star, that is one thing. One thing. Okay, I will write 1, 2, 3, 4, 5, 6, 7. Seven thing. Okay, that's why. Okay, we are writing here step 5. I'll repeat what are the steps we covered till now. What is the first step we did? The first step we did is rewriting and numbering. Rewriting and numbering is the first thing we did. So what is the second thing we did? With the second thing what we did is find the first and follow. And third thing what we did is converting into augmented grammar. What do you mean by converting into augmented grammar? Adding E dash. Reuses E like this. Converting into augmented grammar. Then we understood what is items and what is go to. We just did it. And now we just learned all the states. So after learning all the states, I have to consider the SLR table. So how do you consider the SLR table? S L R table. So this is very important. How to construct SLR table is very important. So this we discuss in the next class. Okay. So for now, you have to please go through the video and understand what we did till the previous step. In the next class, let us discuss the construction of SLR table based on this. So if you prepare and come, it will be easily understandable for you. Okay, SLR table construction, which we will do tomorrow, that is on Saturday. Answer your attendance. If you have any doubts, let me know.